Alright, so now we are on our fourth video, and this is going to be starting at section 2.5. And we have a cool fact. If points ABC are called vertices, when referring to a triangle, these vertices, we use the notation triangle ABC, or the little symbol for a triangle in front of the letters ABC. And why we do that is because, and you need to do this because on tests I do take points off for this, we know that there are other things that we name with three letters like angles. So make sure that you have the distinguisher in front of that, because I do take points off for not having the distinguisher before the letters. Anyway, back to the key fact. The three angles of a triangle always add up to 180 degrees. And let's determine the values of x and y, assuming that m and n are parallel. And I'm going to do a little bit of a notation thing in here. I'm going to use those little arrows in there to indicate that they are parallel. And if they're parallel, we know that we can use all the alternate interior, alternate exterior, same side interior, same side exterior, all those things that we talked about back in the beginning of the chapter. We also know that we can use vertical angles, so if this line and this line cross each other, we know this is also 70 degrees. We know that this is a straight angle, and 70 and 50 makes 120, so that would have to be a 60-degree angle in there. We know that if this is a transversal, let me draw in so you see this as being a transversal, then this side is 60, then x would have to be 60. If on this side of the line, again, we're not talking about one singular angle, it's everything on that side. This angle out here would be 120. We also know that if we have same side interior, tells me that if 70 and whatever this angle is in here has to add up to 180, because same side interior is supplementary. So I'm going to say that that's 110. Vertical angles gets that one to the 110. Now, is there probably 10 other ways you could get those numbers? Absolutely. I just chose those because those were the ones that popped into my head while I was doing it. So we're going to prove that the sum of the measures of the angles of a triangle is always 180 degrees. We're going to start out by, so here's our triangle. This is the triangle that we're talking about. We're going to start out by doing some labeling here, because it's always better to have some labels so I can call stuff. We'll say this is point A, B, C, D, and E. So we're going to use those points, and then we're going to say, hey, DE is parallel, that's the symbol for parallel, BC, and BC is a segment, so I'm not going to get all crazy putting a line above that. Okay? So we know that DAB, let's do a little bit of, because if this is a transversal, we know that angle DAB is equal to angle CBA. DAB, this angle in here, is the same as CBA. And we know that because they are alternate interior angles. So I'm going to write AIA for alternate interior angles there. And we also know we have another set here on the other side. Can I say that this angle and this angle are the same by the same reason? And the answer, of course, is yes. So I'm going to say angle EAC is equal to angle BCA by the same thing, alternate interior angles. And since we're going to call it DE, that line is a straight angle. Now, we've used that fact a couple times, haven't we? That a straight line equals 180. Well, because the angles of a triangle add up to 180 and the straight angle adds up to 180, it's a nice substitution there, which is equal to 180. I'm going to put that in there. So I'm going to say that angle BAC plus angle ACB plus angle CBA is equal to 180. And we can also say, well, if this angle, and this angle add up to 180, which we did right there, then this is the same as that, and that's the same as that. Then we can say that so triangle ABC also equals 180. Now, we haven't talked about the why for that yet, and I'm just going to let the cat out of the bag a little bit here and say it's by substitution. So, by substitution, because we can substitute this angle for that angle for that angle, and both back and forth to get that outcome. Alright, so we have a cool problem in this case. A triangle has one angle that's 40 degrees. I'm going to call this one up here 40 degrees here. And the remaining angles is one is 3 times the measure of the other one. So if that one's x, that one's 3x. What's the measure of the largest angle? Well, I'm going to say that x, 3x, and 40 add up to the 180, which gives me 4x equals 140. So x must be 35. The 3x must be 105. And the last one that we know of is 40. And so the largest angle here is going to be the 105 degree angle. So that's the largest. Alright, so we have another cool problem. Recall that two lines are perpendicular. Now, perpendicular we haven't talked much about. Perpendicular means they run into each other at right angles. So we know that we have the angle of two lines meet at the measure of 90 degrees. So I'm going to say that ADB, this line here, and line M is perpendicular. So I'm going to put that in there. And we know that CEB is 50. I'll put that over there. And we want to determine the measure of x. So we have a couple places in the problem where we have the x measurement. And just for the fun of it, let's use, if this is parallel, that's n, and that's parallel to this one, that's m. I'm going to put these little lines in there to indicate parallel, so I think about that. And if they're parallel, and this is perpendicular, that means by alternate interior angles, that one's perpendicular. And so if we know that this one is 90 by definition, a right angle makes 90. And this one up here is 50, that makes this one down here 40. So we know that. Now, I don't know if that's going to help me find x, but it certainly can't hurt to know that. We also know that if this one down here is 40 and this one's 3x, then this one up here would be 180 minus 40 minus 3x. So if that's true, And I'm going to call this angle 140 minus 3x. And just for the fun of it now, I think I have enough information here to come up with an equation. We know that we know that this angle right here is 180 minus 4x, because x and 3x for the straight line. So I'm going to say that that angle is 180 minus 4x. And so if I take this triangle, and I know that I have 40 plus 3x plus 180 minus 4x has to equal 180, because it's a triangle and all the angles add up to 180. Let's go ahead and do a little bit of solving here. The 180 on this side, 180 on that side go away. I get 40 minus x equals 0, or 40 is equal to x. Now, could there be several other ways to solve that? Again, of course there are. But in this case, I determined that it was x equals 40 by the method that I used. All right. Section 2.6, exterior angles theorem. Basically what the exterior angles theorem says is that this exterior angle out here is going to be equal to the sum of the two non-adjacent interior angles. So non-adjacent means not next to. So leave this one out. These two added up. So x is going to be equal to 136 degrees, because that's the sum of the two non-adjacent interior angles. And here's a proof. You can pause it if you want. I'm not going to walk through it because you can pause it if you want. And let's go ahead and see if we can solve this guy. We know that since this is a straight line, that my x in here would have to be 138 because it makes up a straight line. We also know that this angle here would be 180 minus the 19 minus the 138. Or we could say that y is equal to the sum of the two non-adjacent interior angles, which is that, plus that. And so we know that y would be equal to 157 degrees using the exterior angle theorem. All right. Let's pause here and finish up. I think we're going to be able to finish everything in the last video.